Um, what happens to our economy and our daily lives when artificial intelligence, stops just chatting with us and actually starts clicking, typing, and executing these massive month-long projects entirely on its own?
Yeah, that's the trillion-dollar question right now.
Right, because for the last couple of years, we've gotten incredibly comfortable treating AI like this very fast, slightly know-it-all librarian.
Exactly. You type a question into a text box, it hands you a text document back.
Right. We've been living in the chat interface era, but going through the absolute mountain of data, the white papers and corporate roadmaps we've gathered for today's research, it is glaringly obvious that this era is, well, it's already over.
Oh, without a doubt. It's completely over.
We are no longer just talking to the machine. The machine has literally taken the mouse out of our hands.
And it is a profound architectural shift. Honestly, it's one of the most significant transitions in the history of digital work.
Yeah, which is wild to think about.
It really is.
Welcome to the Deep Dive. I'm Satosha.
And I'm Satoshi. Autonomous agentic frameworks.
The action engines, right. That's the industry term I keep seeing everywhere in the research.
Exactly, action engines. These systems don't just advise you on how to do your job anymore, they actually do the job.
Right.
And what we need to unpack today is that this isn't some speculative, 5 years down the line science fiction. It is the immediate functional reality of how computing is rewiring itself right now.
And because this space is unfolding super fast, let's just stamp the timeline for you right up front. Today is Friday, March 13, 2026, and we are wrapping up the second week of March.
Things are moving so quickly, the date is actually vital context.
Totally. So the mission for this deep dive is to explore exactly what this means for you. We are going to map out the agent war currently raging between tech titans, decode the rise of these action engines, and finally, and I can't wait for this part, we're going to dive into a truly mind-bending economic framework called the Cantillon effect of AI.
That part is fascinating.
It really is. And I'm thrilled we are doing this today because your ability to take these wild, abstract technological leaps and ground them in hard structural economic realities is exactly what we need to make sense of this landscape.
Well, I appreciate that. I think the goal today really has to be looking past the slick marketing campaigns,
No, for sure. Every press release says the exact same thing right now.
Right. You can't open a tech blog without seeing the phrase digital coworker thrown around. But we need to understand the underlying mechanics.
The nuts and bolts.
Exactly. Why is the specific shift happening today, how it actually functions technically, and perhaps most importantly, why this transition is going to fundamentally rewire global wealth distribution?
Because it's not just a software update.
No, not at all. It's an economic event.
Okay, so whether you are an entrepreneur trying to figure out how to scale a business without hiring a massive human team, or an employee wondering if your daily workflow is going to look completely unrecognizable by next year, or, just someone who is insanely curious about the bleeding edge of technology, this transition is going to change how the desktop sitting in front of you operates.
Completely.
So let's get right into it. Let's unpack this shift from the chat interface to the actual desktop environment, because Anthropic has been making incredibly aggressive moves here with a product called Claude Coworker.
Yeah, and Claude Coworker represents a highly strategic pivot in how we interact with large language models.
How so?
Well, for a long time, the bottleneck of AI utility was the copy-paste friction.
Ugh, the worst.
Right. If you wanted an AI to analyze a spreadsheet, you had to find the file, copy the data, switch to your browser.
Paste it into a chat window, wait for the response, and then copy the result back. It's so inefficient.
It's incredibly inefficient. Anthropic recognized that requiring humans to act as the manual bridge between the AI and the work environment just limits the system's potential. So Coworker isn't a website. It is a desktop native agent.
So it sits directly on your operating system.
Exactly. As an active participant with direct access to your local files, your folders, and your applications.
And it's not just reading the back-end code of those applications either. This is the part that completely blew my mind when I was reviewing the technical specs and the research. It's using what is called a computer use loop.
Yes.
Let's break this down because it sounds simple, but the engineering required to make it happen is just staggering. How is this agent actually interacting with the visual screen?
It's a completely different paradigm from how software normally talks to software. Historically, applications communicate via APIs, application programming interfaces.
Right, they pass clean data back and forth invisibly.
Exactly. But the computer use loop doesn't do that. It operates on a continuous four-step cognitive cycle. Screenshot, analyze, plan, and act.
Okay, so step one, screenshot.
Right. The agent takes a high-resolution screenshot of your current desktop exactly as a human sees it. Then, step two, it uses highly advanced spatial reasoning and vision models to analyze that image.
So it's actually looking at the layout.
Yes. It identifies where the icons are, reads the text fields, locates the submit buttons, and understands the visual hierarchy, even if it has never seen that specific software before.
So it's literally parsing pixels, not code.
Exactly, parsing pixels. Third, it forms a localized plan to accomplish the overarching goal you gave it. And finally, step four, it acts. It literally takes over the virtual mouse and keyboard.
It just grabs the mouse.
It moves the cursor to specific X and Y coordinates on your screen, physically clicks the buttons, and types out the text. And then the whole loop repeats.
It takes another screenshot to verify it clicked the right thing.
Exactly. It verifies the click opened the intended menu, adjusts if there was an error, and takes the next step.
It's like having a brilliant, but maybe slightly clumpy intern sitting right next to you who physically reaches over your shoulder to use your trackpad.
That's a great way to picture it, yeah.
It's wild to visualize. And to make this work across different systems, there's this underlying architecture called the Model Context Protocol, or MCP. I keep seeing this acronym everywhere in the research. Why is MCP such a big deal?
You can think of the Model Context Protocol as a universal adapter, kind of like the USB-C standard, but for artificial intelligence.
Oh, that makes sense.
Yeah, it's an open source, industry standard bridge that allows an AI agent to securely connect to diverse, localized data sources.
Because without it, you'd just have walled gardens, right?
Exactly. Without MCP, Claude could only natively interact with Anthropic-approved applications. But with MCP, developers can build secure, standardized connectors to anything.
Like your Google Drive cache.
Your Drive, your desktop email client, or even a highly proprietary custom-built company database. It allows the agent to pull the exact context it needs without you having to manually upload a thing.
Wow. And building on top of that, there's this feature they call skills, which just seems ridiculously practical for the average worker.
It is very practical.
If I understand the research correctly, these are basically reusable instruction sets. So instead of typing out a massive complex prompt explaining your super specific Friday afternoon reporting workflow every single week, you just teach Claude the skill once.
Right.
You let it watch you do it, or you guide it through the steps, and it essentially builds a neural macro.
Yes, but I'd push back on the word macro slightly.
Oh, really? Why?
Because traditional macros are brittle. If you move a folder, a traditional macro just breaks.
Right. It looks for the exact file path.
Exactly. An AI skill is a flexible, reasoning-based workflow. It turns a generalized intelligence engine into a hyper-specialized tool tailored to your exact administrative quirks.
That is so cool.
But if we pull back and look at the bigger picture here, Anthropic's strategy isn't just about technical capability. It's deeply rooted in psychological conditioning.
Yes.
Think about how they have always positioned Claude as a brand.
Oh, absolutely.
Yeah.
The aesthetics are undeniable. The warm sepia tones, the elegant serif fonts. It doesn't feel like a sterile tech product. It feels very, academic.
Yeah.
It's very measured, like a thoughtful professor.
That design language is deeply intentional. When you are asking a user to hand over autonomous control of their personal computer to let a machine open their private spreadsheets, reorganize their folders, draft their emails, trust is the absolute currency.
You got to feel safe.
Exactly. They are applying that thoughtful, careful persona to actual computer use. When Claude starts autonomously sorting your files, they want you to feel a sense of structured, reliable mentorship rather than, chaotic, invisible automation.
That makes total sense.
And it's worth noting the talent driving this. This initiative is coming out of their specialized labs team, which operates almost like an internal startup for experimental frontier products.
Oh, right. Led by Mike Krieger.
Yes, led by industry veterans like Ben Mann and Mike Krieger, the co-founder of Instagram.
Which makes perfect sense when you think about it.
Yeah.
You bring in the guy who helped build one of the most intuitive, globally adopted consumer interfaces in history, and you task him with figuring out how to make autonomous AI feel natural and frictionless.
Exactly the right person for the job.
But let's be honest about where the technology is today. It is not seamless magic yet. For Claude Coworker to function right now, your computer literally has to stay awake.
That is a major limitation, yeah.
The application has to remain open and active. If you go grab a coffee and your screen goes to sleep, your digital intern basically falls asleep at the desk and completely stops working until you wiggle the mouse to wake it back up.
Yep.
Plus, because it is constantly taking screenshots and analyzing them, it eats through your message quota incredibly aggressively. A single session of complex file sorting could burn through the compute equivalent of dozens of standard text queries.
Which highlights a very real architectural bottleneck in this approach. Anthropic's current paradigm for cowork is anchored to the local machine. It relies entirely on your hardware state and your local network connection.
Right. It is mimicking human interaction on a local level. That is an incredible technical achievement, but it is resource-heavy and constrained by the physical device sitting on your desk.
And that limitation perfectly sets up the contrast with the other major player making waves in the research right now, Perplexity Computer.
Exactly.
Here's where it gets really interesting for me. Because if Anthropic is trying to build a brilliant intern that sits locally at your desk, Perplexity is trying to build an entire remote chief of staff that lives entirely in the cloud.
That's spot on. Perplexity Computer is operating on a multi-model orchestration paradigm. Instead of relying on your local laptop state, it operates in a highly secure, isolated sandbox environment in the cloud.
Okay, so how does that look in practice?
Well, you can give it an immensely complex project. Let's say you tell it to research an entire emerging sector like solid-state batteries, design a 20-slide competitive analysis deck, and generate a video summary of the findings.
All at once. Yes. And it goes to work in that cloud sandbox. It does not matter if you close your laptop, turn off your Wi-Fi, and get on an airplane. The sandbox remains active, and the agent continues executing the project autonomously.
The mechanism behind how it accomplishes this is wild, because it doesn't just rely on one single AI model to do all the heavy lifting. The research states it orchestrates up to 19 different frontier AI models in parallel.
Yes, 19.
And just keep picturing an Ocean's 11 crew where everyone has a hyper-specific specialty.
The orchestration harness is the true innovation Perplexity is bringing to the table here. They recognize that the era of the single monolithic generalist model being the best at everything is ending.
Models are specializing.
Exactly. So Perplexity system acts as the master project manager. Let's take your Ocean's 11 analogy. It's not just that they have different specialties, it's that they share a unified, instantaneous hive mind memory.
Oh, wow.
When the central reasoning engine, let's say Cloud Opus 4.6, breaks down the logic of a project, it realizes it needs deep historical data. So it routes that specific research task to Google Gemini 2.5 or 3.0.
Because Gemini is better at that.
Because Gemini has a massive 2 million token context window capable of digesting entire textbooks at once.
Right, it passes the baton. And if it needs to dig through legacy web interfaces or recall long-term context, it tags in OpenAI's GPT 5.2.
Precisely, and if there is a lightweight, rapid-fire factual lookup required, it doesn't waste expensive compute on Opus. It kicks that microtask over to xAI's Grok 4.2 for raw speed.
That is so efficient.
And then, for generating the final visual assets or presentation layers, it leverages Google's VO 3.1. The orchestration harness maintains the state and context across all these different architectures seamlessly.
But practically speaking, what does this mean for the end user? Because orchestrating 19 frontier models simultaneously, passing context windows back and forth, has to be incredibly compute intensive. And compute means money.
It is intensely expensive. This is absolutely not a tool for casual, everyday productivity. You aren't going to use Perplexity Computer to draft a polite email to your landlord.
Definitely not.
This system is exclusively available for their max tier subscribers, which currently comes with a very steep price tag of $200 a month.
$200?
Wow. And even at that price, it operates on a strict credit system. You get an allocation of around 10,000 credits monthly, and different tasks burn different amounts of credits based on their computational complexity.
So you really have to pick your battles.
Yes. The positioning here is critical to understand. This is designed for what analysts are calling GDP-moving decisions. It is enterprise-grade cognitive labor.
It's a remote digital employee that literally never sleeps, never takes a coffee break, never asks for benefits, and has the combined synthesized intelligence of 19 different cutting-edge AI models working in perfect tandem.
And it does so entirely securely. This is a big selling point. Every single task runs in an ephemeral, walled-off container.
Ephemeral meaning it disappears when it's done.
Exactly. It has its own isolated file system and its own headless browser. It is completely decoupled from your personal home network or corporate intranet.
Okay, that makes sense for security.
Though it is worth mentioning that they have recently introduced a dedicated piece of hardware, a Mac Mini they call a personal computer proxy, that stays plugged in and connected to your local files 24/7.
Oh, so effectively blending the local access of Anthropic with the cloud orchestration of Perplexity.
Exactly. But fundamentally, this represents the major divergence we are seeing right now. Local, screen-based execution versus cloud-native, always-on orchestration.
It's honestly wild to think about these specialized models like Google VO, seamlessly generating massive video assets entirely in the background as just one step in a brighter Perplexity workflow.
The evolution of video is incredible.
It really is. The way video generation has accelerated from those weird, morphed, creepy clips just 2 years ago to full cinematic realism is almost hard to wrap your head around. Real quick before we jump into the deep end, if you're getting value out of this show, we request you to check us out on fountain.fm.
It's a value-for-value player where you actually get paid for listening without advertisements blocking your experience.
It's a great platform. And of course, you can listen to us on Spotify, Apple Podcasts, or YouTube Music for free, or wherever you get your daily audio boost.
As for videos, we still need to hit our goal of 1,000 subs on YouTube to start using the Mosaic AI video editor, the one we are talking about in this episode.
Mosaic is truly a game changer for small creatives like us. It really is.
We can feed it a YouTube link, and it creates beautiful AI, cinematic captions, infographics, and a whole lot more we're still discovering in our capability tests.
We can't be more thankful that you all are as fascinated by these deep dives as we are.
And looking at a tool like Mosaic provides the absolute perfect lens to examine the next major conceptual leap we need to discuss: the fundamental difference between specialized agentic autonomy and traditional legacy automation.
Right. Let's get into the no UI paradigm. Because for the last decade, if you wanted to automate a workflow between two different pieces of software, you relied on platforms like Zapier or Make.
Yes.
You connected the pipes.
Standard integrations.
But looking at the trajectory of these new agents in the research, there's a massive question looming over the industry. Is the Zapier era of automation dead?
To answer that, we have to look closely at the underlying logic of how these systems operate. Legacy platforms like Zapier pioneered what we call API-to-API deterministic automation.
Deterministic meaning very strict.
Exactly. They are entirely rules-based. The logic is explicit, rigid, and unforgiving. If this specific event happens in application A, then trigger this predefined action in application B.
It's pure plumbing.
Yeah.
Very rigid plumbing. Let me use an example here to illustrate this without getting bogged down in the math or the back-end code.
Yeah.
Let's say you, as a small business owner, set up a Zapier automation to pull customer email addresses from a specific contact form on your website and dump them into a spreadsheet.
A very common use case.
Right. With traditional automation, the software is looking for a very specific API endpoint or a structured line of code. If your web developer updates the layout of that website or even just renames that data field from email address to simply contact, the Zapier automation breaks immediately.
Instantly.
It has no idea what to do. It just throws a 404 error and stops working.
Right.
But a Vision Action Loop agent, it doesn't care about the back-end code at all.
Yeah.
It literally looks at the newly designed screen, recognizes the little envelope icon or the text box that says enter email here, and it just clicks it, adapts visually.
And that is the crucial defining difference. Agentic AI is reasoning-based, not rules-based. It understands the high-level semantic goal, find the user's email address, and it autonomously charts a course to achieve that goal, adapting dynamically when the environment changes or when obstacles arise.
It's just so much smarter.
Furthermore, it can handle highly unstructured data. It can synthesize a messy, rambling string of text, interpret the context of an image, or even watch a video to extract information. Traditional API connectors are incredibly fragile. They require perfectly clean, structured data arrays to function.
So given that level of adaptability, does this mean Zapier is essentially going the way of the dinosaur?
I would actually challenge that assumption.
Really? Why?
The landscape indicates that rather than replacing these deterministic connectors entirely, AI agents will likely sit on top of them as a management layer. We are moving toward a hybrid stack.
A hybrid stack, meaning both.
Right. The reality is, APIs are still exponentially faster, cheaper, and more reliable ways to transfer raw data natively between two systems, assuming the infrastructure supports it.
Oh, that's true.
You don't want to burn expensive AI compute having a vision model manually copy-paste 10,000 rows of a database.
Yeah.
So the future looks like Zapier handling the reliable, high-speed data plumbing in the background, while the AI agent acts as the cognitive brain.
Managing the flow.
Exactly. The agent manages the decision-making, handles the unstructured exceptions, and coordinates the broader project. And Zapier's fully aware of this. They are rapidly adapting by rolling out Zapier Central, which allows users to build these AI-driven, reasoning-based mini-agents directly into their existing API workflows.
Which brings us back to Mosaic AI, because they represent a totally different, highly specialized philosophy in this space. We've been talking about Claude and Perplexity using virtual mice to click around existing software, interacting with buttons designed for humans.
Right, trying to simulate human actions.
But Mosaic, which was founded by an ex-Tesla engineer named Adish Jain, takes an infrastructure-first approach.
This is a vital distinction to understand. Generalist agents like Claude and Perplexity are trying to master human-computer use. They are interacting with user interfaces that were inherently designed for human psychology and human fingers.
Which is pretty clunky when you think about it.
Exactly. Mosaic is doing something entirely different. They are building an omnipresent API specifically designed for vertical labor in their case, the highly complex labor of video editing. They aren't building a better mouse for the AI to use. They are rendering the entire user interface completely unnecessary.
The no UI paradigm. I am absolutely obsessed with this concept. Let's look at a specific example from their deployment that was highlighted in the research. They built a Slack bot demo, affectionately named Larry.
Larry the bot.
Yeah. Now, if you want a video edited, you don't open Adobe Premiere. You don't mess with timeline tracks, audio syncing, or export settings. Larry just sits quietly in your team Slack channel.
Invisible.
Right. You can ask it to find a specific historical clip of Steve Jobs talking about typography. Larry autonomously hunts down the tape, scrubs through the footage, clips the best conceptual moments, edits them together with appropriate pacing, adds captions, and puts the final polished video file directly into the chat thread.
It's incredible.
It completely, 100% bypasses the traditional desktop interface.
And that is precisely why the infrastructure-first approach is so devastatingly powerful. Having an AI mimic a human using a mouse to painstakingly click through a nonlinear video editing timeline is inherently slow, incredibly compute-heavy, and fraught with potential errors.
Because every click is a point of friction.
Exactly. Mosaic makes the UI redundant. By providing a direct underlying intelligence layer for video manipulation, the agent operates natively in the background at machine speed. There's a fascinating case study circulating in the research right now where a single independent podcaster utilized a suite of Mosaic integrated agents to entirely replace a 5-person production and social media clipping team.
That is staggering. Let that sink in for a second, A 5-person creative production team entirely replaced by an infrastructure-first API living in a chat channel.
It suggests a fascinating divergence in the future of software. While having a generalist AI click around your desktop is capturing all the media hype and the flashy YouTube demos right now, the long-term structural winners of this era might actually be the platforms that render the traditional desktop interface completely obsolete for high-value, specific workflows.
Okay, so if lean startups like Mosaic are building these hyper-specialized infrastructure-first tools to dominate specific verticals, what are the trillion-dollar behemoths doing?
The titans.
Right, because the strategic roadmap shows an absolute titans war going on right now between Google and OpenAI.
It is arguably the most important, high-stakes strategic battleground in the entire technology sector today. Google and OpenAI are not merely trying to build the smartest reasoning tool. That is secondary.
Really? Secondary?
Yes, they are engaged in a war to control the primary discovery interface of the digital world. Whichever entity controls the dominant action engine ultimately controls how human beings interact with the internet, how commerce is routed, and where attention is monetized.
There is an incredible framing used in the research to describe their two distinct strategies. They call it the castle versus the metropolis.
It's a perfect analogy.
Let's start by looking at Google. They're building the castle with a massive initiative called Project Mariner.
Right. Project Mariner, which was formerly known internally under the codename Project Jarvis, is Google's heavily defensive, fortress-like play. They are taking their incredibly powerful Gemini 2.0 and 3.0 models and integrating them directly, natively into the Chrome browser.
Which is brilliant because Chrome is everywhere.
You have to remember, Chrome is the world's most popular gateway to the web. It is the absolute bedrock of Google's empire. It is their castle. By embedding the agent natively into the browser architecture itself, they achieve a zero latency experience.
No waiting for screenshots to upload.
Exactly. The AI doesn't have to take a screenshot, send it to a cloud server, wait for processing, and receive an instruction back. It operates natively within the local environment.
And it uses spatial reasoning to interpret the pixels of the document object model, the DOM, right?
Yes.
So even if a small business website has completely terrible back-end code or no accessible API whatsoever, Mariner can just visually see the page, understand the layout, and navigate it seamlessly.
Just like a human would.
Right. But what really stood out to me was this governance-first approach Google is taking. Why is a company known for consumer search suddenly so hyper-focused on enterprise governance?
Because enterprise adoption is where the multi-billion-dollar recurring revenue contracts live, and right now, corporate IT departments are utterly terrified of autonomous agents.
Oh, I'm sure they are.
The idea of an AI hallucinating and accidentally deleting a sensitive customer database or sending an incorrect legally binding email to a major client is a nightmare scenario for a chief information security officer.
Complete liability.
Google understands this fear, so they built Mariner to generate what they call artifacts. An artifact is a comprehensive, immutable log of screenshots, text summaries, and audit trails for every single granular action the AI takes.
Oh, so a paper trail.
Exactly. This level of extreme security, transparency, and oversight makes the system highly attractive to massive regulated enterprises that require strict compliance auditing.
So Google is building a highly secure, audited fortress designed to win over the enterprise sector. And on the exact opposite side of the spectrum, we have OpenAI building the metropolis with their new agent, aptly named Operator.
Yes. OpenAI's strategy is sprawling, open, and aggressively consumer-focused. Operator is designed as a universal executor model. It isn't tied defensively to a specific browser like Chrome.
It goes everywhere.
It operates across the entire computer operating system. It captures high-frequency screenshots to identify interactive visual elements, and it executes multi-step, complex tasks across any web-based interface or local application exactly as a human user would.
I read about a demo in the research where it was tasked with booking a massive multi-leg international trip. It was navigating flights, cross-referencing hotel availability, booking rental cars, and checking visa requirements across 5 different websites simultaneously.
It's an incredible capability.
And what makes this so real is that OpenAI is actively signing these massive partnerships with companies like Uber, Disney, and various airlines to allow Operator to handle real-world financial transactions directly through the agent.
Exactly. OpenAI is attempting to justify its astronomical valuation by transitioning from a pure AI research laboratory into a comprehensive, ubiquitous digital service provider.
They want to be the everything app.
They want Operator to be the ultimate consumer proxy for the real world. You don't go to Uber's app, you ask Operator to get you a ride. Now, it is critically important to state that we are strictly evaluating the technical and strategic roadmaps here.
Right, absolutely.
We aren't taking a position on which corporate strategy is inherently superior or more ethical. We are simply observing their architectural differences and market approaches.
Google holds a massive distribution advantage with Chrome and Android, prioritizing deep security and governance. OpenAI holds immense consumer brand recognition, sheer agility, and cross-platform flexibility.
And both of these titans are currently racing at breakneck speed to catch up to Anthropic's technical lead in this specific agentic space, right?
Yeah, if you look at specific, rigorous industry benchmarks like SWE Bench, which measures an AI's ability to autonomously resolve real-world software engineering issues, Anthropic's Claude has maintained a highly consistent technical lead.
Though the gap is narrowing rapidly.
Oh, totally. Google's latest iterations of Gemini Pro, along with OpenAI's GPT-5 architecture, are making massive strides in expert-level knowledge retrieval and complex agentic reasoning. The competitive landscape isn't shifting year by year anymore. It is shifting almost weekly.
It's dizzying.
Okay, let's zoom out from the code and look at the real world. We have these armies of AI agents, some sitting locally on our desktops analyzing pixels, some orchestrating 19 different models in a cloud sandbox, some integrated deeply into our browsers.
All working at once.
They are clicking, reasoning, building, and executing complex workflows. What does this actually do to the macroeconomy right now? Because I feel like there's a massive disconnect between the incredible sci-fi level tech we just talked about and what I actually see when I walk into a standard office building.
You are identifying a classic macroeconomic phenomenon, which economists refer to as the productivity paradox. It is arguably one of the most vital concepts to grasp in this entire discussion.
Tell me more.
If you look at the aggregate data, it shows a startling reality. While roughly 70% of firms report using AI in some capacity today, 80% of those same firms report seeing basically zero measurable impact on their employment levels or their overall firm productivity.
Wait, hold on. 80% see absolutely zero impact.
Yep, zero impact.
How is that mathematically possible if these tools can replace a 5-person video production team or synthesize 10 years of financial reports in 3 seconds?
Because there is a profound lag in organizational adjustment. Having a new tool is not the same thing as knowing how to use it at scale. This is a recurring pattern in the early stages of any general-purpose technology cycle.
Like what?
Let's look at a historical parallel. When electricity first replaced steam power in manufacturing, factory productivity didn't immediately spike. In fact, it stagnated for years.
Why? Wouldn't an electric motor immediately make a machine faster than a steam pipe?
You would think so, but you have to understand the architecture of a steam-powered factory. They were built vertically, multiple stories high, around one massive central steam shaft. Belts connected every machine to that single power source.
Okay.
When electricity arrived, factory owners simply took out the steam engine and dropped a massive electric motor in the exact same spot in the basement. They kept the complex and efficient system of belts and vertical shafts. They just swapped the power source.
Oh, wow.
It took an entire generation of management to retire before new leaders realized they didn't need the central shaft anymore. They realized they could put a small electric motor on every individual machine, which allowed them to build factories horizontally and optimize assembly lines. That is when productivity exploded.
So right now, having an AI agent isn't the same as knowing how to restructure your entire business around the capabilities of that agent. We are just dropping a massive AI engine into our old vertical steam shaft workflows.
Exactly. Right now, companies are buying thousands of enterprise AI subscriptions and essentially asking their employees to use them to execute the exact same legacy processes, just slightly faster.
That's a waste of potential.
The true seismic productivity gains won't be realized in the aggregate GDP data until organizations completely tear down and redesign their operational workflows from the ground up to be AI native, like the infrastructure-first, no UI approach of Mosaic we discussed earlier.
But the investment money is certainly flowing, regardless of whether middle management has figured out how to use it yet. The capital expenditure numbers in the research are staggering. Tech giants like Meta, Alphabet, and Microsoft are projecting a combined capital expenditure of $342 billion in 2025 alone. That is up 62% from just last year.
It is an infrastructure investment boom unlike anything we've seen since the rollout of the global fiber optic network.
It's insane.
This capital is entirely focused on building the physical foundations required for autonomous intelligence, massive data centers, advanced cooling systems, power grid infrastructure, and specialized silicon chips.
And what does that do to the economy?
Well, there is a fascinating complexity to how this impacts domestic GDP in the short term. A massive portion of that $342 billion doesn't stay in the local economy.
Where does it go?
It flows directly out of the United States to international supply chains, specifically to foundries in Taiwan and memory manufacturers in Korea to purchase the physical hardware. So while it represents a massive corporate capital outlay, it actually subtracts from immediate domestic GDP growth in the short term due to the import balance.
And what about the actual human labor impact? Because at the end of the day, these are the numbers that keep people awake at night. The research points out some intense exposure rates: 75% for office and administrative support roles, 68% for business and financial operations. And McKinsey is actively projecting that 45% of middle management coordination tasks will be fully automated by 2030.
Those are significant numbers.
They are. But I want to push back on the doom and gloom narrative for a second. Exposure to AI does not automatically equal unemployment, right? Just because an agent can parse a spreadsheet doesn't mean a human is automatically fired.
That is a critical distinction, and you are entirely correct to push back on the simplified narrative. Exposure simply means the fundamental nature of the daily tasks within that role will change. It does not strictly dictate job loss.
Right.
In fact, for many high-wage specialized occupations, AI acts as a powerful complement rather than a substitute. If you are a high-level corporate strategist or a senior financial analyst, an AI agent that can instantly synthesize 10 years of global SEC filings doesn't replace your strategic judgment. It allows you to make exponentially better, faster, and more informed
It
decisions.
makes you superhuman.
It raises your individual cognitive output and, theoretically, your value to the firm. The friction and the displacement will be felt most acutely in roles that are purely coordinative or administrative, the middle management tasks of routing information from point A to point B.
Right, the scheduling, the drafting of routine briefing notes, the manual data entry. If you are trying to set up a meeting with 5 executives, the AI doesn't just suggest a time. It autonomously negotiates across 3 different time zones, cross-references calendars, books the virtual room, and prepares the background agenda automatically.
And the human coordinator in the middle is bypassed.
Exactly.
However, for a macroeconomy like the United States, being the earliest adopter of these autonomous systems provides a massive strategic cushion. Even as the broader domestic labor force growth begins to slow down significantly due to aging demographics, the sheer volume of productivity output generated by these AI complements will add significant resilience and potential growth to the overall economy over the next decade.
It's a tremendous amount of data to process. The 70-80 productivity paradox with the factory electricity, the $342 billion in capex flowing overseas to chip manufacturers, the 45% automation of middle management tasks.
A lot to take in.
If you are listening to this on your commute or at your desk and feeling slightly skeptical of these massive numbers and sweeping projections, we completely understand. The key to this vote of confidence is the research we share on our website.
Exactly. No login needed, no cookies, no trackers, and absolutely no advertisements.
So please, if you want to dig deeper into the numbers, check the link in the descriptions, because today is a big one.
Huge.
And honestly, that skepticism is deeply healthy, because questioning the surface-level narrative leads us perfectly into the final and arguably most profound implication of everything we've discussed today in the research. Aggregate GDP growth, or how much more productive society becomes as a whole, actually matters far less than the structural mechanics of who exactly receives that newly generated wealth.
Which brings us to the Cantillon effect of AI.
I had never heard of this economic theory before reading through today's materials, but it's absolutely fascinating once you grasp it. Let's break this down historically first. Richard Cantillon was an 18th century economist.
Yes. Richard Cantillon was a banker and philosopher who observed how new money physically entered an economy. Specifically, he was looking at what happens when new gold or silver was discovered, or when a central bank printed new fiat currency.
Okay.
The prevailing assumption was that if you double the money supply, prices just instantly double everywhere. Cantillon realized that inflation does not happen evenly or instantaneously.
It takes time to spread.
Exactly. The people physically and institutionally closest to the printer, the governments, the large banks, the major asset holders, receive the newly created money first.
Right. So because they have the new money first, they get to spend it before prices have risen in the broader market. They buy up land, commodities, and real estate at the old, cheaper prices.
Exactly. And as they spend that money, it slowly ripples outward through the economy. By the time that new money circulates down to the average rural farmer or the broader working class population, the money supply has expanded, causing general inflation.
Prices go up for everyone else.
The latecomers find themselves dealing with significantly higher costs of living for rent and food, while their wages haven't yet caught up to the new reality. Therefore, the first receivers of the money gain massive unearned purchasing power, while everyone else effectively takes a hidden pay cut.
That structural, chronological redistribution of wealth from the latecomers to the first receivers is known as the Cantillon effect.
Precisely.
Okay, so that perfectly explains historical money printing. But the framework we are looking at today argues that we are currently seeing a completely new issuance mechanism. In the 21st century, we aren't just printing fiat currency, we are essentially printing intelligence.
It is a phenomenal, highly conceptual economic framework. Artificial intelligence represents a massive, sudden injection of near-zero marginal cost cognitive labor into the global economy. And just like fiat currency in the 18th century, this new intelligence does not diffuse evenly across society.
It bottlenecks.
Yes, it enters the economy through very specific, highly concentrated institutional bottlenecks.
The massive capital concentrations, the frontier labs building the models, OpenAI, Google, Anthropic, and the massive enterprise partners who secure early high-volume access to these action engines. They are the modern first receivers of this printed intelligence.
Precisely. The sectors closest to immediate scalable monetization are the first to integrate these autonomous agents. High-frequency financial trading firms, algorithmic ad tech networks, global logistics conglomerates, and surveillance tech.
They get the intelligence first.
They utilize the massive injection of intelligence to radically optimize their profit margins, capture massive market share, and aggressively reduce overhead costs long before the broader consumer market has even figured out how to write a highly effective prompt.
And this leads to a massive structural shift in inequality. We have data in the research referencing a model calibrated by the International Monetary Fund, the IMF. And I want to make sure I get this right because it feels deeply counterintuitive at first glance.
It does.
The IMF model predicts that AI might actually shrink wage inequality across the labor force, but it will massively widen wealth inequality. How does that math work?
It comes down to understanding the specific nature of the tasks being commoditized by this technology. Previous automation waves, like the introduction of factory robotics in the 1980s and 90s, primarily displaced blue-collar, routine manual labor.
Right, the assembly line jobs.
This actually widened the wage gap because highly educated white-collar workers saw their premium rise while manual labor wages stagnated. Agentic AI is fundamentally different. It targets high-end, cognitive, white-collar tasks, software coding, legal contract analysis, financial modeling, and medical diagnostics.
Expensive tasks.
Yes. As AI commoditizes these traditionally high-income tasks, the wage premium for that specific specialized knowledge drops. Mathematically, this pulls the top salaries down closer to the median, shrinking the wage gap across the board.
Okay, let me use an analogy here to avoid getting lost in the data econometric math. Let's imagine you work at a manufacturing firm. Because AI has automated the complex accounting and legal work, the highly paid executive accountant and the floor manager start making paychecks that are mathematically closer together. The wage inequality between employees shrinks.
That's right.
But the person who owns the manufacturing firm, or in this broader modern context, the individuals holding the tech stocks, the private equity portfolios, the index funds, their assets absolutely skyrocket in value because the firm is now hyper-productive and running on highly efficient autonomous agents.
Exactly.
It honestly doesn't matter if everyone's paycheck gets slightly more equal if the asset owners are capturing 99% of the newly generated corporate productivity gains.
That is an exceptionally clear analogy. Wealth inequality, which is driven by capital returns rather than hourly wages, is projected to widen significantly. The IMF model projects a substantial shift in capital allocation. High-income workers, despite facing potential downward wage pressure on their salaries, are usually the exact same individuals who hold the largest share of their total wealth in risky, high-return financial assets like firm equity, stock options, and defined contribution pensions.
They own the stock.
Those financial assets directly absorb and reflect the productivity gains captured by the AI integrating corporations. So, the capital owners, the equity holders, become the modern cantillionaires.
And I want to pause right here and make sure we are crystal clear on something. It's important to point out that we're looking strictly at the IMF's economic modeling here. We aren't taking a stance on the politics of wealth distribution. We aren't advocating for left-wing taxation or right-wing deregulation. And we aren't validating one economic system over another.
No, absolutely not.
We are simply breaking down the mathematics of how this specific structural model views the future of capital and productivity to help you understand the underlying mechanics of what might happen.
Absolutely. The objective here is pure analytical understanding of the mechanism. The Cantillon effect of AI suggests that by the time the average consumer fully integrates these sophisticated tools into their daily personal life, the structural redistribution of economic wealth will have already occurred at the top levels of the market.
It will be too late.
The bottleneck isn't the intelligence itself eventually. Generalized AI intelligence will become as cheap and ubiquitous as electricity. The true bottleneck is control over the deployment infrastructure, the proprietary interfaces, and the incentive design of these agentic systems today.
So whoever is first wins.
Those who control the action engines right now are actively shaping the enterprise legislation, the cultural norms, and the capital flows of the digital economy before a broad social consensus can even form.
It creates a massive self-reinforcing cycle. The early institutional beneficiaries use their new intelligence advantage to secure even more computational resources and market share, further widening the gap between the first receivers and the latecomers. It is a fundamental rewiring of who captures value in modern society.
A complete rewiring.
If you are listening to this right now, and your retirement is in a standard index fund, You are passively participating in this wealth transfer. But if your sole income is tied to administrative coordination, your exact job description is the target of this commoditization.
Which is exactly why the strategic imperative for both businesses and individuals is no longer just learning how to use AI to write faster emails. That is thinking too small. It is about understanding the architecture of autonomy and positioning yourself or your firm as a first receiver in this intelligence issuance.
Wow. Let's zoom out and look at the massive big picture here as we wrap up. We are actively transitioning from a world where human beings are the primary users of digital tools, clicking, dragging, typing, manually transferring data, to a world where humans are essentially shifting into the role of managers of autonomous digital labor.
The action engines are officially here.
The chat interface era we've lived in for the past few years, that was just the training wheels to get us comfortable talking to the machine. Claude is living locally on the desktop, analyzing pixels. Perplexity is orchestrating massive model clusters in the cloud. And tech titans like Google and OpenAI are fighting a tectonic war to be the very lens through which we view the internet.
It is, without hyperbole, the most significant technological and economic paradigm shift of the century. But I want to leave the audience with one final, highly speculative thought to consider, something that wasn't explicitly modeled in the macroeconomic data we covered today, but represents the inevitable next step of this architecture.
What's that?
If the first receivers of AI wealth are deploying their agents to aggressively optimize their corporate gains and margins, what happens in 5 years when a massive enterprise's highly aggressive, profit-maximizing AI agent tries to negotiate a dynamic price directly with your personal, always-on desktop AI agent? When the algorithms start serving us and start autonomously negotiating against each other in real time over resources, bandwidth, and pricing, who actually wins?
That is a terrifying, brilliant, and deeply complex question to end on. Who wins when the agents negotiate against the agents? We want to know what you think. If you have expertise in AI orchestration, automation infrastructure, or macroeconomics, we want to hear from you. Drop into the comments and join the conversation, because we are all navigating this unprecedented frontier together. Keep searching, keep the quest on. See you on the next deep dive. I'm Satosha.
And I'm Satoshi.